Okay, so here are problems 30 and 31 worked out. I've actually already worked them out, so I'll walk you through the answers. So we have one here with two obvious asymptotes. One here along the y-axis, and then one in a negative line running straight through the origin. So for domain and range, it will be negative infinity to 0, and then 0 to infinity, with a union symbol in the middle. It's not just negative infinity to positive infinity because of this asymptote here. And because of that, the graph stops existing at 0, so we have to mention that with a unity. Range, I actually could not figure out. I did my best, but I couldn't figure it out. Now, vertical asymptote, like I said, is 0. So you represent that with the line equation x equals 0, saying these are all x values along the 0 point on the x-axis. This has no horizontal asymptotes, as there are no just perfectly horizontal lines running through it, with dashed lines. And there are also no oblique asymptotes, as there also are none. There are also no intercepts. I didn't put it down, but it wasn't any to begin with, so it's okay. But there aren't any because none can touch the y-axis because of the asymptote, and none can touch the x-axis either because of the other asymptote. So that is the whole problem with 30. Here's 31. 31's actually more straightforward for some reason. So the domain is negative infinity all the way up to negative 2. Because at negative 2, we have a vertical asymptote and we have to stop. And then we union that with negative 2 to 2. Then we union that once more to get 2 to infinity. So you would have to stop every single time because the graph stopped existing at these asymptotes. If you tried to plug it in, it would just return undefined, because it was dividing by 0 in the case for rational functions. Range is somewhat the same. We go from negative infinity all the way up to 1 right here because the graph stops existing, and then we union that with a 1 to infinity because the graph exists from there on. Vertical asymptotes, we have x equals negative 2 and x equals 2. There are two vertical lines that the graphs don't exist on. We use these to determine domain and range. So we write those down, x equals negative 2 and x equals 2. Horizontal asymptotes, there is 1, y equals 1, because remember, the graphs up here couldn't touch it. This one doesn't reach up to it, but it couldn't touch it nonetheless. So that is y equals 1, and then there's no oblique asymptotes because all these lines are perfectly like horizontal or vertical. So the only intercept is negative 1. I think I just noticed a mistake with my range. I believe it's actually from negative infinity to negative 1, because there is no graph from negative 1 to 1, despite the possibility of there being one. So the range would only be from negative infinity to negative 1. I actually want to fix that pretty easily, just to add a negative. But this 1 to infinity stays the same because we can't go from negative 1 to 1 because there's nothing there. So the range of this graph ends at negative 1. Yeah, because see, those points don't reach down either. So there's just a gap here that we have to account for. And then it goes from 1 to infinity when these kick in. And that, as those two problems worked out, don't mind that macroeconomics.